All right, let's continue now and look at the dominant versus recessive traits. This is kind of a fun one. If you've taken biology, then you may have done something with this before. This is related to those, I think they call them pundit squares. Isn't that how they're in a biology class? So here we're looking at a particular disease, cystic fibrosis. It says it's pretty common inherited disease. Occurs in about 1 of every 2,000 Caucasian births and 1 of every 250,000 non-Caucasian births. So it's more likely to happen in Caucasian births than in others. All right, then we're going to use a little c to represent the cystic fibrosis gene and a big C to represent the disease-free gene. Okay. And we do that here because the disease is recessive. Now what that means is if you get a little c from one parent and a little c from another parent, that's the only time that the person would actually wind up having the disease. And then it goes on with some sad information that people that wind up having the cystic fibrosis, actually having the disease, wind up typically not having children. They wind up passing away before they ever have kids. A child could, though, get the disease if they have parents that are what we call carriers of the disease. So capital C is a disease-free gene, but a little c means that is the cystic fibrosis genes. People who have a big C, little c actually wouldn't be sick, but they would carry that little c gene and could potentially pass that on to their child who might get a little c gene from another parent, and then that would wind up causing them to be to have cystic fibrosis. All right, so you're going to have questions like this in homework, maybe with different diseases. Okay, but what's happening on the first question is, the first one just wants to know what's the empirical probability that cystic fibrosis will occur in a randomly selected infant birth among U.S. non-Caucasians. So pay attention to which type. This one was non-Caucasian, so non-Caucasians. So I should use this stat. So that's actually what 1 of every 250,000 means. You have a 1 out of 250,000 chance that the baby might have cystic fibrosis. Now they asked for this to 6 decimal places, so we're going to divide. All right, this calculator didn't know how to fix that. Okay. Let me do it on my phone. All right, so I'm going to clear that. 1 divided by 250,000 would be 0.12345 That's what it is to 6 decimal places. So basically, these ratios that you see up here actually are the probability of having cystic fibrosis for each of those types for Caucasian births or non-Caucasian births. Okay. Now, the second type of question gets into the genes that are passed on. So here, suppose that both partners in a marriage are cystic fibrosis carriers. We want to figure out the theoretical probability that their child might have the disease. So cystic fibrosis carriers are big C, little c. So we could think about, say, the mom is big C, little c, and the dad is big C, little c. And they're going to get a contribution from each of them. Let me make that one look a little smaller. Okay. So then you look at the possible outcomes. This is your sample space. Big C, big big C, little c. Here, little c, big C, or little c, little c. All right, so that's the possible outcomes. And the question was, what's the probability their first child will have the disease? So to have the disease should be 2 little c's. So that would be just that one possibility out of 4. Okay. Would be the theoretical probability. All right, now this says, suppose a child is born to one cystic fibrosis carrier parent and one non-carrier. Okay, so first let's get this. Carrier would be big C, little c. Non-carrier means they don't even carry the gene, so they're 2 big C's. So one parent is big C, big C. The other one is big C, little c. So we'd have big C a couple times. Here we'd have little c, big C, little c, big C. Now it says find the probability the child will be healthy but be a carrier, a healthy cystic fibrosis carrier. So they carry the gene, but they don't actually have cystic fibrosis. They're just carrying it. But you see how there's 2 possibilities out of 4? Okay, so the probability in that instance, if one parent was big C, and the other parent was big C, little c, so this is the non-carrier parent here, and this is the carrier, healthy but a carrier, healthy but a carrier. Okay, then we have 2 chances out of 4 of having a child that carries the cystic fibrosis genes.